Well, first of all, I'd like to thank everybody for all the help and advice and tips. It's fantastic. I get some really good tips. And I'd like to mention a few names really. Tony in California contacted me. He's making a farm boy hit and miss as well. And I think he's sort of a little bit ahead of me, which is no surprise. But he sent me some pictures of a governor that he's made. And I find that in the drawings, it's very difficult to sort of get a good picture of certain parts of the engine once it's assembled. It's very good at sort of giving you the dimensions of individual components, but sometimes for me it's hard to visualise how some of these things actually join together. I'm sure once I've made them all, it'll all sort of fit together. I really appreciate these pictures of the governor. So I'll show one or two of those when I get around to that stage of the build. Flywheels. I got loads of advice on flywheels, and I followed loads of sort of sites up. A lot of the suppliers just didn't have anything close to what I needed, which is 6-inch diameter flywheels, and I think they're just under an inch in sort of thickness. And Roderick and Andy both came up with a name of a guy on eBay, or name of a site on eBay. Pedelee 56, so that's Pedelee 56, and I went on eBay, typed that in, couldn't find him at all. But what one of the guys suggested, well, searching for, and I quote, model making steam engine cast iron flywheel. So I put that into Google, and hey presto, it found Pedelee 56 on eBay, and sure enough, he had a casting which was just about perfect for what I wanted, but he only had one of them. So anyway, I contacted him, and he said he could sort me out with two, and a week later I got these, and these are really good quality. I mean, I don't know much about cast iron. I assume they're cast iron. But you know, I'm used to sort of the Stuart castings, which, you know, seem to have a lot of tidying up to be done, but these are ever so clean. So, you know, obviously they need machining, but I'm really happy with the quality. And I think that's it really. Richard Perrin, who's also building a farm boy, he sent me a casting for a cross drilling jig to make for the lathe. So at some point in time I'll have a go at that. So anyway, in this video what I'm going to be doing is looking at assembling the gears for the Jerry Howell farm boy hit and miss engine. Okay, so way back when I did my first video, I made the gears, and I couldn't get any 48 pitch gear cutters, so I decided on mod 0.5 gear cutters. And at the time I worked out that the difference between centres between the 48 pitch and the mod 0.5 difference is only about 3 thou. But I never actually drilled the hole for the camshaft, which needs to go there. So what I've decided to do is, what I need to do is centre on the main bearing, and then move the table that way by 1.026 of an inch, and then I need to move it this way by 0.450 of an inch. But obviously first of all I need to make sure I'm centred on this bearing. Which I am. So while I'm here, there are some more holes I think that need to be drilled and maybe tapped. I think one down here as well, but I'll do all that off camera. Well, that turned out to be a bit of a disaster, because having drilled the cam gear shaft, or the hole for the cam gear shaft, I sort of did a quick assembly of the gears, and the gears are too tight. So I've just revisited some maths here. Now, the original drawing suggested 48 dp gears, so I can work out that the cam gear pitch diameter is equal to 1.5 of an inch. The crankshaft pitch diameter is equal to 0.75 of an inch. So the distance between centres is 1.5 plus 0.75 divided by 2, which gives 1.125 of an inch. Now, my mod 0.5 gears have got a DP of 50.8, but if I work out the pitch diameter of the cam gear, I get 38 millimetres. The crankshaft is 19 millimetres, so the distance between centres is 38 plus 19 divided by 2, which is 28.5 millimetres, which actually gives me 1.1220 of an inch between centres, which is less than the 48 dp gears. So in theory, if I follow the dimensions in the drawing, the gears should run with a bit of slop in them. In anything, it's supposed to be tighter. So something doesn't add up really. So if I look at the dimensions on the original drawing for the between centres measurement, I can see that the centre of the crankshaft here compared to the centre of the camshaft, there's a difference here of 1.026 along that sort of plane, and then on this plane here there's a difference of 0.450 of an inch. So using sort of Pythagoras theorem, I can calculate this distance that I'm going to end up with if I follow the dimensions on the drawing. And if you work it all out, we get this distance as coming in at 1.12035 of an inch. Well, that's smaller than the 48 dp gears by 5 thou, and it's smaller than my mod 0.5 gears by 2 thou. So something's not right. I can't believe that the drawing's wrong, but the maths suggests the drawing's incorrect. So what I've decided to do is I'm going to have to have another go at this and change these dimensions slightly to give me a bit of an allowance here for the between centres. So my revised calculations are going to be, I'm going to opt for this measurement here as being 1.029 of an inch, and we'll keep this distance here as being 0.450 of an inch. And if you use Pythagoras theorem, you actually come up with the distance between centres of 1.1231, which is fine because my mod 5 gears come in at 1.1220. So to me that's perfect. I've got a thou clearance. So what I'm going to have to do is I'm going to have to drill the hole out that I originally drilled for the cam gear. I'm going to have to plug it with a piece of aluminium. Going to have to glue it in there with Loctite or something, and then I'm going to have to set the piece up on the mill again and drill to these dimensions. So what I've decided to do is just put a temporary shaft through the main bearing, and I've repositioned the centre of the mill 3 thou off what it states in the drawing. So this is reading 1.029 as opposed to 1.026 of an inch. on the x-axis, so 3 thou out. And I've just put this temporary shaft in here, and that turns really well. So with that in mind, what I'm going to have to do is I'm going to have to plug the hole I've already drilled. I might open it up a bit and then plug it, and then re-drill at this position. But hopefully we'll get there in the end. Well, that looks really good. So what I need to do now is to make the camshaft. Well, the camshaft will fit in there, and it should be a fairly straightforward component to make out of this piece of silver steel, 15mm in diameter. And once it's made, it'll need to be hardened and tempered. So this needs to be reduced down to a diameter of 1/4 of an inch over a length of 0.748 of an inch. So there's quite a lot to come off this, around about 340 thou in total. So divide that by 2, it's around about 170 thou. So there's just 5 thou to come off this using fine feed. It looks spot on. Test fit. Yep, that looks good. Well, that looks good. So what I need to do now is machine this front piece on the milling machine. Okay, so this end needs to be made into a cube shape, with each side being, let me see, 3/8 of an inch in length. And I know for a fact that the dimension of this bar here is exactly 15mm in diameter. So I know the radius is 0.75mm, which equates to 0.2953 of an inch. Now I need to get this down to around about 0.1875, so 3/16 of an inch. So if I take 0.1875 off 0.2953, I get to 0.1078. So rather than machine it right down to that level initially, what I'll do is I'll probably go down to, let me see, 100 thou all round. I'll check the dimensions and see how close we are to 3/16, and then do some final machining to get it down to that particular dimension. So that's all faces machined down to a depth of 95 thou. So I'll double check the measurements and then hopefully we can do the final cuts. Okay, so the outside dimensions at the moment are 0.3880. So if we take 0.375 off that, we get to 13 thou. Divide 13 thou by 2 and it's 6.5 thou. So I'm going to take 6 thou off each of the faces and we should be pretty close. So off camera I use this little slot drill just to open that up, and then I ream through. Now I did harden it, I heated it up so it was red hot and plunged it in some water, but I've not tempered it. I'm not sure I need to temper it. I need to read up on tempering, but anyway, the end result is really good, really happy with that. Well, while I was waiting for the silver steel to arrive to make this little camshaft, I thought I'd experiment a little bit more with making springs, and I thought I could probably improve on the intake one. So I took a little bit of footage in terms of what I did. Well, I thought I'd have another play around and try and make the valve spring a bit more accurately. The one that I've got in the head is slightly over diameter in size, and I've ended up turning this mandrel down to a size of 0.233 of an inch in diameter for size 7 wire, and it produces a pretty close outside diameter of 0.4. I think it comes in about 0.39, and I think, you know, these are my 4 attempts. Some of them are pretty good, and I think that's my best one. It's a pretty close match, so I think what I'll do is I'll replace the one that's in the head with that one. Now, when I was having a go at making those springs, I used this Machinery's Handbook, 12th edition, dated 1944, so that's what, 76 years old. And it had some information in here about arbor sizes or mandrel sizes, or whatever you might want to call them, and for spring making, and I just couldn't work it out. There's some really useful information in here though. But then I thought, well, it's probably time to buy a more up-to-date one, so I got this one, and believe it or not, I opened it up, page 341, and there's a really simple table that tells you the sizes of the mandrels to make springs. And for an 18 thou piece of music wire, it tells you that if you want to make a spring with an outside diameter of 3/8 of an inch, the mandrel needs to be 0.231 of an inch in diameter. Now, that's ever so close to what I ended up with. I mean, obviously my spring size was slightly bigger than that, but I ended up with a mandrel size of 0.233. So this book's already coming useful. I'm not a one for reading novels. In fact, I've never read a novel in all my life. But I can read technical manuals till the cows come home. I love them. Stuff like this and computer programming books, you can't beat them. So anyway, in terms of the gears, I'm really happy with the way they've turned out. Goodness knows why the drawing appears to be wrong. I don't understand it. If others have come across that problem, it would be great if you could make a comment or leave some feedback, because I'm sure my maths are right. But anyway, I hope you like the results so far, and I hope to see you later.